Okay, now coming to the discussion, continuing the discussion related to the checkpoint. I said what is dirty pages and what is clean pages. Okay. Mm, Dirty pages is nothing but the pages the buffer manager will extract, pull the pages in the cache. After pulling that pages in the cache, some operation is happening to that respective page. Due to that operation, some updation, insertion or deletion or something maybe among those three operation is happening to the certain rows of that page. Now this page to which it is buffer manager is already fetched and doing the operation. Now this page is having some operation, some modification when compared to the which is available in hard disk. The LSN number here, LSN is generated for each operation. We compare with the LSN number. The LSN number of the page available in B buffer pool and available in hard disk is difference. That means that file is dirty. Okay. If the same, that means the file is clean. Okay. So LSN number is updated continuously to the page header, but checkpoint is there. It is there some object whose responsibility is to pull that flush the dirty pages to the hard disk. Okay, checkpoint object is the responsibility, but checkpoint object it need to know which page is dirty. Okay, then we have thousands of pages available in the cache only, RAM buffer only. Then checkpoint will need to search 1000 pages and its header. No, it become a problem. Problem is unnecessary. It need to go to all pages. That's why for each page one memory object is created. One rough structural object is created. That object we can say as a BUF object. We set that object name as a BUF. Okay, so that BUF object for each file, for each page, data page, we have BUF object. Then it's what it is storing. It is storing what is the LSN number when it is fetching. Okay, and what is the current LSN number, and this BUF object belonging to which database, and in the database belonging to which page ID. Okay, and whether based on that LSN number it can track whether clean or dirty, and how much space available to that page. It is also stored in that object only. Then one important thing is we have, whenever we get the memory pressure, need to free up the memory. At that time, suppose cleaner take the rest, checking first which page I need to clear from this buffer. Okay, it is thinking. It check first. It uses the least recently used algorithm, from which it identify that whatever page which are not used but just it is stored in the RAM, and some pages which is frequently used, that is mostly used page. It means this algorithm need to know based on that cleaner will remove the page. So that field also it is storing like LSN, least recently used algorithm for cleaning purpose. And these are the fields what I am. Next one another field is like each page. This is the page. Each page contain log object. So number of thread need to get the access, but to avoid that access we are creating the log object. That log object will be stored in this BUF. Okay, finally we said that BUF structure contain the actual LSN number during the fetching which is available in hard disk, and the recent LSN number. For each operation LSN is generated, that means log record is generated, that log record LSN number is stored in the page header. That LSN number will be stored in this data block buffer BUF data object, and it is for filtering purpose it is belonging to which database and which ID, page ID. And for least recent used algorithm for cleaning purpose it is stored in the priority and it stores the log object. Okay, and anything I missed? So buffer pool has a set of data file pages in memory, and every one of these pages a little control structure called BUF structure associated with it, and that track a whole bunch of things for the page. You can think it is the state of the page which is required for the buffer pool for some operation. So that's it.